Okay. Is everyone comfortable with the recording? So first, let me spell out the guidelines. Please keep your mic muted during the session. If you have any questions or issues, please message us in the chat and we'll help you out with that. If you have any questions regarding the topic being discussed, you can ask them after the session. Also, if you have any internet issues, no worries, since you can just hop onto our YouTube channel and check out Simply Neuroscience and rewatch the event. Now let's move on to the bio. Dr. Ubadah Sabbagh, PhD, is a neuroscientist at the McGovern Institute at MIT, where he is a postdoctoral associate in Dr. Feng's laboratory. Dr. Sabbagh attended community college for 3 years before transferring to the University of Missouri, Kansas City, where he earned his bachelor's degree in biology. He later earned his PhD in Translational Biology, Medicine, and Health at Virginia Tech, where he studied connections between the eyes and the brain. Outside of the lab, Dr. Sabbagh is highly involved in science outreach, advocacy, and policy. He co-founded and serves on the board of Black Neuro and has written extensively on topics at the intersection of science and policy, with articles published in the Washington Post, Scientific American, and other publications. His contributions have been recognized in many ways, including most recently being named to the 2021 Forbes 30 under 30 list. Dr. Sabbagh, on to you.
Hi, thank you, Vishnu, for the introduction, and to Simply Neuroscience for inviting me here. Yeah, so I'm Ubadah, and I have, I came to the US maybe 12-ish years ago and started off in community college. Then I went to college, eventually found my way to grad school. It wasn't a straight path, but we'll probably talk about that in a little bit. But yeah, I don't have much to say other than I'm happy to have, a discussion, hopefully, with you and with the audience, as informal as you guys want. I'm very happy to just chat. It's supposed to be a fireside chat, but I can't set fire to the building here, and there's no fireplace.
Yeah. Also, it would be greatly appreciated if you guys switched your camera on to make it more interactive. Right. So to start it off, let me ask some questions. Could you please tell us more about your background and the journey overall through neuroscience?
Through neuroscience. So my background is, in terms of my degree, my undergraduate degree was in biology, with a specialization in bioinformatics, which is computational biology. And but at that time, really, I didn't know what is graduate school and what is. I never took a neuroscience class or a psychology class or anything like that. I just read a couple of books, and that made me, develop an interest in the brain. I was always interested in behavior and sensation and how information from the outside world is processed by the brain into a representation of how we see the world and how we interact with it. So, during undergrad, I just developed an interest in research, and then I had a professor who was the one who encouraged me to apply to graduate schools and to pursue a PhD. And at that time, I didn't know anybody who had a PhD or was in grad school, and so I thought that it was only for wealthy, like rich people and people who like to write books. That was what I thought a PhD was, is that you are rich and you write books. I didn't know what else is involved. Turns out you don't have to be rich and you don't have to write books. And so he kind of like explained a little bit to me, what is the day-to-day like, and then I started applying to graduate programs. And I applied to different ones, not just neuroscience, because I had wide-ranging interests and I just wanted to pursue research. But in the end, what felt right was neuroscience, and it also wasn't just about what felt right, but also who accepted me, because we can talk about that too, because there were struggles there as well into getting into grad school. But yeah, once I started in neuroscience, I got really into molecular neuroscience, trying to understand how the complex circuits in the brain wire up during early development. And the system I chose to study was the connections between the eye and the brain. And so, during early development, the retina is growing out axons, or basically wires, like output wires from the retina into the brain. And then they connect with dozens of different brain areas in a very organized fashion. And so the question I had was basically, how do they know where to connect? How do these wires that grow during early development know what brain areas to target and what kinds of connections to form? And that is more of a molecular question, because there's probably molecular signals that say, come here, don't come here, connect with me, don't connect with me. And so during my PhD, that's what I started off wanting to do, is trying to understand how that development happens. And it took me in different interesting directions. And I ended up, identifying new cell types in the brain that are receiving visual input from the retina. And that was really fun to do. And then after that, after I finished my PhD, which was last year, I started my postdoc, which is something that you don't have to do. Like, it's one of the things that one can do after getting a PhD, is a postdoc, which is short for postdoctoral fellowship, which is literally what it sounds like. It's just some more research, more independent research that you do as a postdoctoral scholar. And so that's where I am now. I started my postdoc here at MIT, and I'm still interested in brain circuits, but I'm less interested now in how they develop, and I'm more interested in how they work, specifically in the context of psychiatric disorders like schizophrenia, for example. So yeah, that's kind of like my neuroscience background. I'm going more from molecular is where I started, and now I'm going in the direction, I think, of more circuit systems neuroscience and hopefully behavior as well.
Very cool. Thank you so much for that. On that note, for all the potential and current grad school students, do you have any advice?
But for all potential graduate students,
yeah,
or current and potential graduate students, do I have any advice? Yeah, I think, I mean, grad school is, especially if you're on Twitter, like, you'll always see negative, things about the graduate experience, about grad school. And there's a lot of truth to that. It's not like a walk in the park. It's not easy, but it's also not like a nightmare. And it doesn't have to be. But I think a really good thing to do is to try, if possible, to get some kind of research experience before entering graduate school or applying to graduate school. One, it's good for your CV, but it's also good for you to be in that setting to see how you feel about research and the pace that research takes place in. Most of the time when people are doing research, it's not exciting in terms of like the day-to-day. You don't wake up in the morning and you're like, I'm so excited to troubleshoot this thing that hasn't been working for the last 2-3 weeks. It's kind of a grind, right? But the exciting part is the prospect of discovering something, that the potential to answer a question that's burning for you. But some people are happy with that kind of thing, and other people are surprised to find, how the challenges of regular scientific research are. And that can lead to being in kind of a miserable situation, because maybe you realize, oh, this actually is not for me. It's not the kind of thing that I enjoy doing on my day-to-day. So that's another good reason to do research. Try to get some research experience beforehand. Unfortunately, there's not too many funded opportunities to do that. Sometimes you can find summer research programs, summer fellowships, things like that. I've written about that before, and kind of explained how those kinds of things work. But if you can find any paid internship or fellowship that gives you a few months of research experience, and if you're able to volunteer and not be paid, That's another way to do it, although everybody should be paid for their work. It's just unfortunate that there's not always people who will pay. So I think those are good things to do if you're considering grad school. If you're going to grad school or you are a graduate student already, I think one thing that I really think is important is to try not to compare yourself. It's very easy to say, very hard to do. Try not to compare yourself to your peers, because everybody's journey is going to be different, and they come from different backgrounds than you. They might have, maybe you feel like, oh, they're more knowledgeable, or they have more research experience than me, or something like that, and then you feel smaller, or you feel, you know, behind or something. But in reality, there's no ahead and behind. It's really just like, are you on your way to becoming the best scientist you can be? And they're trying to become the best scientist they can be. And it's less about comparing yourself to them and trying to compete with each other, and more about trying to support each other through grad school. So that brings me to my next point, which is community. For me, I found to be very important. I still find it to be very important as you do science and navigate academia. So early on as a graduate student, try to identify the people who you will feel supported by, who will, you know, be there for you and you'll be there for them. There's going to be lots of difficulties, whether they're science related or personal or academic related. You know, you're taking classes in the first year or two in grad school, and that's a lot to do while you're doing research. So you need like a support team, and if you can find them in your graduate cohort, that's a very it's very powerful. It really helps you make the process more fun, and on the tough days you find support. So I think community is important, not comparing yourself to other people and just trying to set bars for your own self. And then maybe the third thing is, you know, try to be self-reflective and think about your goals. And it's okay if they change. Like, just check in with yourself once every whatever few months, once every 6 months, whatever it is, every year. Try to, you know, there's this thing called, what is it called? My IDP. It's called IDP, Individual Development Plan. It's for free. You can go online, look up IDP, and you can try to develop your own plan for how to, once you have a goal, you know, how are you going to develop yourself to reach that goal? A lot of people coast during graduate school and don't take the time to reflect on what's important to them and what career goal they have or scientific interest they have, because these things shift. The more expert you become, the more your ideas will shift and your professional goals will shift. And so try to always check in with yourself and see how you're feeling about things, because then it'll help you make better decisions for your next steps. And that way, you know, you're trying to make sure that you're happy while you're doing the things you're passionate about, instead of feeling trapped and too invested in something that you no longer care about. So yeah, I think those are maybe top 3 things. I mean, I could give advice like, you know, do well and study and whatever, like, yeah, do those things. That's obvious. But I think community and self-reflection, self-awareness are very important things that the sooner you start thinking about them, the better.
All right, cool. There are 3 more questions in the chat. So if you could answer those.
Okay. Which
Okay, I could read them out for you. So the first one,
if you could, please, yeah.
Yeah. So she asks, I would like to know more about your grad school application process and how you chose to pursue a postdoc after grad school, and what other options are available after you finish a PhD.
Okay, that's a great set of 3 questions. Okay. I'll answer the second question first, because it's the fastest one I can answer, which is, how did you choose a postdoc? I wrote a very thorough article on this that a lot of people seem to have found helpful, and you can find it on my website. It's called the Postdoc Guide, and it really details exactly my thinking, and even has tools there. It's of course free, and it has like some tools of how I organized my thoughts and ideas, and you can download like an Excel sheet to help you with that process. But I'm also happy to talk about it here. I'm just saying that there's a resource there that I put together because I get asked this question a lot about the postdoc. The first question was about the grad school application process. So I told you that I had a professor who like told me, hey, you should consider doing a PhD. And he said that because I did some research with him for like 3 months over the summer, unpaid. And but he, even if he wanted to pay me, he didn't have the money to. So he was like, okay, you know, it seems like you enjoy research, consider grad school. And then I looked into it, and this was like around, I don't know, like October maybe. The deadline for grad school applications is usually early December. And so I didn't know, for example, you had to do a GRE. So all of a sudden I find out that you have to do a GRE. I studied like 6 days for it. I didn't have money to pay for courses or whatever. So I just got like a secondhand book for the GRE. And then I took the exam. I took the exam and I performed okay. I wasn't like amazing. It's probably like, you know, average performance score during that year. But after I took the GRE, I applied to 11, I think, graduate programs, PhD programs. I got 0 interviews, 0 invitations. It's completely failed that whole year. And so this was my last year of undergrad, my 5th year. I did 5 years of undergrad. And so, of course, it was very like discouraging and stuff, but I didn't know so many things. I didn't know that your application essays need to be personalized. Like you need to, now that I say it, of course, I'm like, obviously, like you need to have personalized essays for each program. But at that time, it wasn't obvious to me because I literally didn't know anybody who's done this. So, so I didn't have mentors either to help me through that process. So your applications need to be personalized. I didn't know that you can reach out to professors before you even apply or after you apply. You can reach out to professors in that program that you're interested in potentially working with and be like, hey, like my name is Ubadah. I think your research on blah, 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 whatever is very interesting. I'm applying to the neuroscience grad program. And I would love to, you know, talk about potentially working in your lab. You know, I didn't know that you can do that. I didn't know you can correspond. And in fact, a lot of people do that, build relationship or some kind of rapport with PIs, which PIs is principal investigator, for those who don't know. It just means professor who runs a lab. People build relationships or rapport, at least, with some PIs in the department they're applying to before they apply. And that's really helpful because then that helps, because when it comes time for the admissions committee to be processing applications, that PI will go to their colleague and be like, hey, this person, you know, told me that this person reached out to me and we had a chat and they seemed very eager, very motivated, very curious, you know, talented, has potential. So like, you know, basically look carefully at their application or whatever. And if they say that, you know, if they like you so much that they're like, I have funding, I'll take them if you accept them, then that's kind of like almost you're guaranteeing your slot in the graduate program. It doesn't always happen that way, but the point is I didn't know that these were options. So you know, so anyway, I also applied in my first year. I applied to a lot of big programs in terms of like in prestigious places, which was honestly a mistake because it doesn't matter as much where you're doing your PhD in terms of the university's name. It's more about the lab that you're doing it in, the PI you're working with, the department. And so anyway, and I also ended up, unfortunately, because I didn't know that you can have application fee waivers and I didn't have money. If you are in some income bracket, you don't have to pay application fees. They're waived and you can ask for it to be waived. And I was in that bracket, but I didn't know this. So I ended up like having over $1,000 on my credit card to apply to these programs. It's really expensive, you know, so, you know, lots of lessons learned. Anyway, so I got a job after I graduated undergrad. I got a job as a medical lab technician, processing blood and urine samples, doing medical testing, like when you go to the doctor and they draw your blood. I did that for a year. And during that time, I prepared applications again and applied to grad schools again. And I think I applied like to 8 programs the next time. And I got into like 1.5. Like the half was like somebody on the fence. So, but the one like full offer was from Virginia Tech, and that's where I ended up going. And honestly, it was like maybe like the best place I could have landed for me. So it was very like nice serendipity. So in my case, you know, it was lots of luck and some resilience. So hopefully anybody here who's planning to apply, just because you're at an event like this already, you're ahead of where I was. So I think, you know, you're going to have a better experience. If you want to see all my failures, I also have that on my website. I put all the graduate programs I applied to and got rejected from, just to show people that it's okay, like sometimes to fail. It's not only about like what's on the CV is only the successes. You don't see like the kinds of things that you might experience on the way to the success that you'll eventually have, hopefully. There was a third question, or is it 2? I'm going really slow, aren't I? I'm talking too much.
So
what other options are available to you after you finish the PhD, right?
Yeah, that was the third.
Yeah, so I mean, if you want to stay in research, there's many options. There's academic research, that's usually postdoctoral fellowships or positions. Sometimes you can find like a research coordinator position or a lab manager position that's for like a highly skilled person, like a PhD level person. If you are interested more in being part of research but not doing the research yourself, if you're interested in doing the research yourself, there's postdoctoral positions in academia, and there's also things like research scientist positions where you're basically like a super postdoc. You're like a PhD level scientist in the lab, but you're not planning, you're not gonna like go on the market for faculty positions. That's not your goal. Your goal is just to develop your independent project and be working on it in a lab. So those are the academic options. Research options outside of academia, there's tons, and they pay way better, right? So there's pharmaceutical companies like this building right here, right there, that's Moderna. And this, I'm at work on Sunday. But you can work at places like, you know, Moderna, Pfizer, Novartis, like a lot of different pharma companies. If you want to work in research and development outside of academia, you can also work in biotech startups and non-startups that are in biotech. There's of course pros and cons to all these different career options. And then if you don't want to work in research, there's also tons of stuff you can do. You can get into science journalism. You can get into science communication in terms of working as a communications director, for example, at a research institute, and talk about the science to the broader public that's happening in your research institute. You can get into science policy, and we can talk about that. You can work in government, or you can work in nonprofit world, advocating for research. So there's many options actually. Then there's, you know, other like specific career paths, like medical science liaison is one. I can tell you it exists. I can't explain what it is because I'm not very knowledgeable in that job. But there's lots of options. It's not just academic. In fact, the hardest one to probably get is a faculty position because it's just the market is insane. You know, it's too tight. So if you have interests outside of academia, nurture them and try to do internships here and there and see what you enjoy.
All right, very cool. So the next question from Chinmai is, so the first question you answered, you were talking about Twitter, or the second one, sorry. And so on the note of Twitter, how would you recommend leveraging the platform as neuro students or professionals?
This one I don't have a good like recipe for, because I don't use it strictly in a professional way. I'm just kind of myself on there. Like I make the same stupid jokes on there that I make in real life. I also share papers that I think are interesting. I engage in discussions that I think are interesting and worth engaging in. Not all discussions on Twitter are worth engaging in. But I think one really powerful thing about it despite the fact that it can be sometimes like, a hell site, Twitter, just messy, is that it really helps you find some people that you might otherwise not connect with, especially during, the last couple of years. It's been hard to go to anything in person anywhere. And even before that, you might not be in a position to be funded to go fly somewhere and go to a conference and stuff and to meet people. But like platforms like Twitter allow you to connect with peers and maybe even more senior people who you share interests with, or personality, or whatever it is. And it's nice because then you are building a network of people that you talk to and learn from and benefit from. So, how to leverage it, I would say, yeah, again, I really don't have a good strategy here, except like be yourself. Don't try to pretend to be something you're not. And, engage, if somebody shares something that you think is interesting, like tell them that, you think it's interesting, thank them for sharing. Or if you read something interesting, like, post it and talk about it and say why it's interesting to you, and maybe people will engage with you. I think just like engage with people who you think are cool and interesting, and eventually, you'll find a network that is interesting, like that you want. But also, some people use Twitter as lurkers, essentially. Like, you don't have to be active on Twitter. You can just have a Twitter account and see the discussions that are happening, or see the papers that are being shared, or whatever. And you don't have to participate as you are completely in control. So, I know Twitter has like this new thing for professionals. I genuinely don't know what it is. I just remember somebody sent me something about it and I didn't read it. But like, there's a thing where you can be like having a professional profile. Maybe look into that. I don't know what that is though. I'm sorry, I don't have a very useful answer here, other than like, it can be a nice place, and you can find job opportunities, you can find very cool papers, you can find cool people, and try to avoid the toxicity. Mute whoever you want to mute, don't follow whoever you don't want to follow, and you don't have to engage with everything. That's another thing I think people fall into the trap of. They engage with everything. Not all topics are good for Twitter. Some things are nuanced, and Twitter is not the place for that.
Right. So I guess the main message there is to network with cool people.
Yeah, people who you find like you have some shared interests with.
All right, cool. So Chinmay's second question would be, would love to learn more about how you got involved in science policy and advocacy. Were there any hurdles you experienced as an early career researcher?
Yeah. Okay, so this was really fun for me during grad school. So this is when I first got involved in it. So I've been involved in policy and advocacy, which are actually different things, but they're related in different ways. I actually got busy during grad school. So one thing that is a straightforward advocacy thing that I can talk about is called the Hill Day. This is specifically if you're based in the US. I don't know how distributed, what's the distribution of our audience here, but if you're based in the US, Hill Day refers to Capitol Hill, Washington, DC. And it's a day where a bunch of professionals like in your field. So if you're a neuroscientist, probably through the Society for Neuroscience, or through, if you're a neuroscientist or any other scientist, the American Association for the Advancement of Science, AAAS, that's a society that does Hill Days. There's many different scientific societies that do Hill Days, and it essentially is a bunch of scientists going to Capitol Hill, to DC, for a day and having a bunch of meetings with different offices of Congress people or senators. You basically meet either with the staff of the member of Congress, or you meet with the member themselves, and you basically talk about the importance of biomedical research and its value to society in terms of cures and in terms of economic, growth, and and you advocate for something. And usually there's like a little training that happens beforehand that they tell you, okay, this year we're all asking for $2 billion increase to the NIH, which is the primary funder of biomedical research in the US, in the budget. So we were asking Congress to increase the NIH budget by $2 billion because we are trying to keep up with inflation, right? And so everybody in their meetings is asking for the same number. And the goal is that by doing this kind of advocacy during the budget writing process, members of Congress will then increase the NIH budget that year. So I've done this for like 4 or 5 years, and it's really fun and it's very cool. And you meet other cool scientists and you get to go to the Hill and meet people. So that's a nice thing. And you can find opportunities to get it funded through your societies. So like, look up your professional societies, website and see if they have something like a Hill Day or advocacy fellowship or something like that. Society for Neuroscience has something called ECPA. You can look that up, Early Career Policy Ambassador. That's an opportunity that you can get funded to go do this. AAAS has AAAS, the organization has a workshop and Hill Day thing called CASE, C-A-S-E. You can look that up and you can get potentially funded to go do that too. But another way of doing science advocacy is using social media. Like if you have a cause that you care about, let's say, whatever it is, like using model organisms in research and the value of them, or whatever thing that is worth advocating for. I cared a lot about international students and international postdocs in the last few years. Like we're having multiple different attempts to ban visas for F1 visas and J1 and H1B, and so I used social media to talk about that, and I also wrote some articles to talk about it and the damage that kind of policy would cause. Social media is a good venue for advocacy. Another thing that you can do is if you want to be involved in policy, there's the problem is with a lot of these things, my intuition, my experience is only restricted to the US. And so I'm sorry about that. But that's the only system I've done science in. I'm not even from America, but this is where I developed as a scientist. So when we talk about policy, you can think about, people usually talk about two different kinds. There's policy for science and then there's science for policy. And so policy for science is basically if you want to be part of shaping policy to further science or to support science in the country that you're in. And science for policy is basically if you're trying to go the other way around, which is trying to push for evidence-based policy making, right? So if you're talking about epidemiology and virology and whatever, you want to push for evidence-based public health policy. If you're talking about antimicrobial resistance, same thing. You want to push for policy based on what the science is saying. The other way around is you want to influence science through policy, and that could be through advocacy, like I mentioned, or it could be through working for a government agency that regulates science and sets policies for science, like the NIH, like the National Science Foundation. You can work in the White House at the White House Office of Science, Technology, Policy. There's internships there that one can apply to. If you're in grad school, there's a fellowship called the Science and Technology Fellowship from AAAS again, and they fund you for a year, I think, or 2 years, and you get matched with some federal agency to work there during that time as a science policy analyst or a professional in some capacity. It can be in Congress or in the executive branch in the White House, or it can be even now in the judicial branch. And then there's another fellowship that grad students can keep an eye out for, which is a very good one called the Mirzian Fellowship with the National Academies of Science. It's like a 3-month fellowship, also paid, and you can do it during grad school. That's something to have an eye on if you're interested in getting into policy. I think I'm happy to answer more questions about it, but I think I threw a bunch of information out there. I'm sorry I don't have much guidance on international or non-US based opportunities. I just don't have experience there, in case anybody needed that.
Oh, cool. Very interesting. So the next question from Tima is, any tips for an undergrad wanting to start their own research project instead of working under a grad or post-grad student in the lab?
I think that, so not, and in terms of tips, I don't have any tips from experience because I didn't do that. But I think that, you know, if you feel very strongly that you have an idea that you want to develop, like your own research project, talk to the mentor, talk to the PI about it, and go have a meeting. You know, if you have the ability to be communicative and transparent with them, tell them like, hey, like, you know, I've been reading the literature, and it seems like there's a gap in knowledge here. And I think this would be an interesting, project for me to pursue. Like you know, think about the experiments, the first experiment or two that you would need to start that kind of project. Think about them and tell the PI, hey, I like have thought about what I would do to start this, and this is what I would do for the next, you know, month, let's say, or whatever. These are the first like couple of experiments, just to show that you've been putting thought into it, and see what they say. Like, try to have a conversation about it. I think it shouldn't be your priority as an undergrad to develop your own project. If you want to, that's great, and try and have a conversation with your PI about it. But the priority or the most important thing to get out of it, I think, is just being involved in a project and having the research experience. Some of it is not just like the technical work that you're doing with your hands. Like, part of the value is the conversations you have about the research with the mentor that you're working with, whether it's a grad student or a postdoc. Because you need to, you know, even as a graduate student and as a postdoc, you're always developing your intellectual skills, your critical thinking skills. A lot of this job is like thinking of the right question to ask and the right experiment to do. And so that is a skill that needs to be developed. People are not, the idea that somebody is a genius and always knows the right thing to do is like, it's kind of, excuse me, bullshit. But like, it's mostly like you need to, you know, these are skills to develop. And so just working on a project with somebody, hopefully, is an opportunity to develop those skills. And so for an undergrad, I wouldn't say the priority is to be independent, but if you want to be and you feel comfortable and confident in that, think about what you would do and go talk to your PI about it and say, hey, like, I'm enjoying, you know, working with so-and-so on this project, but I have this idea that I think would be a cool project for me to pursue. I even thought about the first experiment or two. Here's what I would do. My hypothesis is this. Here's how I would test it. And a PI would love to see something like that. Ordinarily, like, you know, it's nice to see somebody taking initiative like that and being passionate and showing that they want to develop their own work. So that's maybe my advice.
All right.
I just realized something. Sorry, one last note. So the question, I don't know, it's a little ambiguous. If the question is like, start your own research project outside of any lab or start your own research project within a lab. My answer is that I just gave is within a lab, starting your own research project. If the question is about starting a research project outside of a lab, like on your own, I don't have any useful advice there. I would say try not to, and just go try to join a lab. Yeah, okay.
All right. Okay. So the next question from Inshara, it's a fun one. Do you have a favorite neuroscience related book or article that you would recommend to students?
Oliver Sacks, The Man Who Mistook His Wife for a Hat, is a great book, I think, that talks about prosopagnosia, which is a kind of face blindness. That was just something that got me thinking, and he's an excellent, was an excellent writer. The Telltale Brain was a book that I read as an undergrad that got me interested in neuroscience. I also have an affinity for intersections between art and science. And there's a book called Reductionism in in Brain Science and Art, I think it's called, by Eric Kandel, who is a Nobel laureate in neuroscience, and he's currently in Columbia University. That's just a book I really like, because Eric Kandel is also like very passionate about art and art history. He's from Vienna. If you go to SFN, you might catch him. I don't know, like now after the pandemic, or during the pandemic, if he's going to be going to in-person meetings, but he's a very, like, he's always there, and you won't miss him. An old Jewish guy in a bow tie. But anyway, he's really into art history and arts, and so it's a great book. Eve Marder has a book called Lessons from the Lobster, I think it's called. Also a great one to check out. In terms of articles, yeah, there are articles that I think are cool, but I just don't remember them off the top of my head. It's like bookmarked, on my computer somewhere, like a bunch of them that are like interesting. But yeah, I think maybe those are books that come to my mind right now in this moment.
All right, cool. Also, I can second that The Telltale Brain is an amazing book. Even I got into neuroscience through that book.
Who was it? Was it V.S. Ramachandran who wrote
V.S.
it?
Ramachandran, yeah.
Yeah, okay, yeah.
It's an amazing.
I can't remember who wrote it. Yeah.
Okay, here's a follow-up question from Nandini. Is the AAAS fellowship open for international students? Do you also know other fellowships that international grad students in the US can apply for?
Great question. So the AAAS fellowship, I don't recall, but I suspect you have to be a graduate student. You have to be a permanent resident or a citizen, I suspect, because you're working in the government. But I'm not sure, and it's very easy to find out. Just go to AAAS's website, look up Science Technology Fellowship, and see the eligibility. In terms of the other question of opportunities for graduate students, international graduate students in the US, in terms of grant, like research fellowships, not too many, but there are. This is one of my biggest frustrations, is the paucity of opportunities for international students to develop their CVs in the US, because a lot of opportunities are for citizens and residents. But one fellowship that you can look at is called the PD Soros fellowship. I think you're eligible for it in your first one or 2 years. That's one to look at. I can't remember off the top of my head right now specific names, but they exist, and I can tell you where you can find them, which is maybe I can. Okay, there's no time for me to look up a link and put it in the chat box. But if you look up Johns Hopkins Vice President of Research website, right? They have a list, like an Excel sheet you can download, that they update very well. And I know the team who's working on this, and they're very diligent about it. And this is a great service to the community. Pre-doctoral fellowships is what you want. And you download that Excel sheet, and you can sort it by fellowships that international students are eligible for. And so that is a very good resource. Another website to check out that has this information organized as well is pathways-to-science.com, I believe. You can look for, they're sorted, you can sort by international students opportunities there. And another one, by the way, all these websites I'm mentioning, also if you go to my website and you go to, there's a resources, under the resources tab, there's links. All of these are listed there. So you can find Pathways to Science there, Johns Hopkins thing there. There's a hyperlink to it. And there's one to Cientifico Latino, which is a nonprofit that does great work here in the US. But they also have a very good database that you can organize and look for opportunities for international students. So they exist. I just don't know them off the top of my head. But there are those opportunities. The AAAS fellowship, you can easily look up, but I don't remember it off the top of my head either.
All right, cool. Also, Chinmay put in some good links in there. So the next question from the audience, how did you get started at Black Neuro? What initially drew you to neuroscience, and what is the new neuro program at MIT like?
Okay, how did I get started in Black Neuro? It was very organic. I didn't know the team, like now the team of Black Neuro, I didn't know all of them at the time that we started. Essentially, our current president, Angeline Dukes, she tweeted out sometime in 2020, you know, when is there going to be a Black Neuro? She just tweeted out that kind of question. And then a bunch of people were in the replies, you know, saying that, oh, it should be done and all this stuff. At that time, actually, I was busy. It was evening and I was busy doing other things. And so I wasn't really online, but a bunch of people started tagging me, like my phone started getting notifications. So people who knew Angeline and knew me, but I didn't, like just mutual people were saying like, oh, let's like get Ubadah involved in this. And I didn't really understand what was happening. And so I just like replied like, whatever it is, like add me to a Slack if you're making a Slack and I'll check it tomorrow. Like, I don't know what this is. And then the next day I was in a Slack with maybe 21 people, other people. And I knew personally 5 or 6 of them and the rest were new people to me. And then we got together and decided we're gonna try to start a Black Neuro Week. Not a Black Neuro organization, but Black Neuro Week, an event to highlight and empower Black scholars in neuroscience. And we just worked like phenomenally together. It was great chemistry. And within a month, we put together a massive event. It was covered in multiple news outlets, and I was part of the fundraising and the website development. And we were able to pay everybody who participated in our programming an honorarium, whether they were an undergrad or a professor. Everybody was compensated for their time, and that was thanks to our fundraising efforts. And then eventually we realized, oh, this is growing into something bigger than what we usually anticipated. So we started thinking about, okay, formalizing it into an organization. So my involvement in Black Neuro was very organic. Of course, I'm not Black, and the organization is led by majority Black people. And eventually, there were internal elections had, and then there was a board that was elected, and then the board appointed me to stay on the board for a longer term. And so I'm mainly now involved as a board member for things like long-term vision and strategic planning and stuff like that. But yeah, it's a fantastic organization and just wonderful people who do a lot for the community. So yeah, that's the answer of the Black Neuro question. I don't remember the other question that you asked me.
What initially drew you to neuroscience?
I think I kind of addressed this earlier in the talk, which is essentially, a natural interest for human behavior and also how we process, the sensory world outside of us and how that motivates our behaviors. So I think that was the initial draw. And then as I, got into neuroscience, I started developing, other neuroscientific interests, which I'm now trying to pursue as a postdoc. But I never took a class, is what I said earlier. Maybe the questioner joined a little bit later, but I never took a class in neuroscience. And so I didn't have that kind of foundation. I just read a couple of books that we mentioned earlier, and those were ones that also sparked my interest in it.
And the last question was, how is the neuroscience program at MIT like?
Okay, so the department here is called Brain and Cognitive Sciences. That's where I'm affiliated at MIT, and they have, of course, an undergraduate program and a graduate program. I can't tell you really in detail how it's like because I've been here less than a year, and I'm here as a postdoc, and there's been lots of virtual classes and stuff like that because of Omicron and other things here. So I haven't lectured in any of the classes yet, although I plan to So I can't give you like too much detail into how it is. I can just say that, there's a lot of, very creative people here. I have interacted with a few of the students, and they seem to be, very, very curious and passionate about the work that they're doing. And of course, there's a lot of resources here in terms of networking that you can tap into, and in terms of funding for research ideas and stuff like that. So I think, I have a positive, perspective on it, but I don't know details to be able to say like, this specifically is a major strength of the program and this is a major weakness. I don't have that knowledge yet, because I feel like I'm still a relatively new person here.
All right, cool. Another question from the registrant. Please tell me what glooming career paths are there in neuroscience and how to apply neuroscience in our daily life.
What's the word? Blooming?
Glooming in the sense that it's, in the limelight right now.
Careers in
Yes.
neuroscience.
Yeah.
Careers. I don't know, like in terms of like jobs that are now really hot that weren't hot before. I don't know. I mean, the question I'm usually used to is like, what fields are like really hot right now and weren't hot before or something, but careers.
I guess
I think
you could modify that and change it to fields.
Yeah, I mean, even the fields question is hard, to be honest with you, because like it just depends on who you ask. But I think there's a lot of interest in developing like brain-computer interfaces or brain-machine interfaces. Oh, I see Chinmay wrote neurotech. Yeah, that's what I'm getting at. So there's, this is a thing that, there's a lot of hype about right now, trying to interface between the human brain and machines or computers, and for therapeutic reasons or for enhancement reasons. I think usually these things start off as for therapeutic purposes. Let's say if somebody needs a prosthetic and you're trying to make a neural prosthetic for them, or somebody can't type or can't talk, and you develop tools where they can think of what they want to say, and a computer will type it or say it out loud. Multiple different applications for these kinds of things. So that's a thing right now. It's like on at the interface of like intersection of neuroscience and bioengineering. I think gene therapy is a thing that is now also like really exploding. Delivering drugs to the brain is a thing that I'm also like involved in this right now as part of my one of the projects I'm developing, is trying to develop viral tools that are circuit specific or cell type specific that can deliver whatever it is that we need to deliver to whatever part of the brain we want to deliver it to. So I think drug delivery to the brain is a tough problem that a lot of people are currently like interested in working on, and in academia and outside of it. And gene therapy, being able to treat neurodevelopmental or psychiatric disorders by gene editing tools, as it's also something that's exploding. And I would say, yeah, what Chinmay mentioned, which is neurotech. I hope I'm saying your name right. Yeah, I don't know. I never got that question before. Hot careers. Yeah, there's always going to be postdocs if you want to do that. That's never going to be like a shortage of postdoc opportunities. I feel like there's always postdoc opportunities. There's shortage of faculty opportunities. But yeah.
All right, cool. Do we have any other questions? If we don't, since it's been almost an hour right now, any final remarks, Dr. Sabbagh?
Well, first of all, I mean, I'm thankful to the audience for engaging. I always like to have a chat rather than just give a talk. And yeah, I think, I think one important thing that I keep noticing is that that I think people don't do enough and should in science is the self-reflection thing I talked about at the very beginning. Check in with yourself to see how you're feeling about your work, the questions that you're asking, the interests that you're pursuing. Are they still your interests? Are you still passionate about this work or not? Have conversations with mentors about that, and think about your goals, your professional goals, and what they are. They don't have to be what your grad mentor or your postdoc mentor or your just the PI of your lab's professional aspirations are. You have your own journey, and that goal, those goals might change too. And so thinking about them and having conversations with friends and colleagues about them helps you refine your thinking and really nail down like what is the thing that I'm really passionate about pursuing. And just keep doing that, because I think unfortunately a lot of people find themselves in a position where they just kind of were on autopilot for a while, and then they ended up working on projects they don't care about anymore, or in labs they never wanted to join and only joined for the wrong reasons, and usually for prestige reasons, which is never a good reason to join a lab on its own. And then they realize, they're in a position that they don't want to be in, and thinking about what kind of professional identity you want to have, what kind of research interests you wish to pursue, thinking about that regularly will help you be a better scientist and a happier scientist. And if you're going to be in academia, I don't know why one would stay in academia unless they're happy, because there's so many other things that are, constraints, including being underpaid at every level that you're in. So it's important to make sure you're happy, check in with yourself and your mental health, take steps to care for yourself, and surround yourself by a network of people who will support you, not just professionally, but also personally, because all of that is important to your success as a scientist. And I only say this as my closing thing because there's lots of other advice people will give, right, about how to be a successful scientist, and all of that is probably like valid, but I don't hear this one talked about as much as it probably should be. So yeah, I'd say that's probably my final remark.
All right, very insightful. Thank you so much for that. Thank you so much, everyone. It was a tightly knit audience, perfect for a fireside chat. And it was very interactive as well. So again, thank you to Dr. Sabbagh and the wonderful audience. Have a nice day.
Thank you.
Bye.